There's a nucleus. There's an electron. So there's a K shell, there's a L shell. Okay, let me not show. Can you hear me?
Yes, sir.
Okay,
Yes, sir.
no electric power. With mobile data will continue. Huh? No, there's a nucleus. Some particular nuclei have a proton and they would increase the neutron. So here they can go for capture. So this nucleus will capture the innermost electron. So maximum it will 80% of the nucleus will go for capture of K shell. Very less are there where L shell will be there. Okay, yes, brought now X-ray emitted is telling. X-ray emitted. Why that one? So a capture will this will jump the. I do like some nucleus. So this will be, say we'll take, this is X, this will have Z, and A will take it. So after capture, what will happen to the number of nucleons will remain same. No? I think the charge will decrease. It will become Z minus 1. And who can fill up the vacancy, and it can be filled up by the electrons. No, 4. And now the vacancy created in the L shell, K shell can be filled up by the electrons transition from L. So this electron what I'll pick up and it will make a transition. So here we'll get a LK alpha. They may trouble you with data like this. Usually just in books we have, I think in chemistry, you just go for only some K alpha thing. So in physics, what happened? I can bring a numerical. No, X-ray emitted will be characteristics of parent nuclei, daughter nuclei is saying something here. First of all, what about the energy released in the process? This should be equal to mass of beryllium. I think there's a beryllium, no? And we also have the neutrino. If you look at the reaction, this is the daughter. K capture occurs. Then, so there's a parent. This is a daughter. Tell me what will happen to this daughter nuclei? The kinetic energy of lithium nucleus. So lithium nucleus, the daughter is nearly, is asking that, will it recoil? Yes, it will recoil, but its energy will be very less compared to the energy carried by this one. So here the neutrino, I will bring the diagram in the system. The linear momentum, you can show it. No, this will KY and the neutrino what happened will take like this. So they say recoils. The daughter nuclei recoils here. Daughter nuclei No, in the neutrino that was released in the beta decay, you don't get like a, so like you can say like a, will it be monoenergetic? No. Here in the key capture, what you get, no, the neutrino will be monoenergetic. Getting this one? So there it was the energy will be shared between beta and the neutrino in the beta decay. It depends upon the chance. But here what happened? The neutrinos will be monoenergetic. So what are the that is be monoenergetic? Also, in case of beta decay, the neutrinos will be monoenergetic. It's also very important feature to remember. Okay, how to get into K5. So first we'll do this Q is equal to mass of beryllium. There's a mass of it mx minus my into C. Mass of beryllium of lithium in calculation 0.16929 minus 0.016004 into 1 AMU. 940 or this we have to do calculation. The difference of these two, 7.01629 minus 7.016004, 0.0925, but 3 zeros, 925 into 940 into 940. Zero 0.8695. This much of energy is available. Energy now shaped in the has to be so momentum of daughter should be equal to momentum of can you hear me?
Yes, sir.
Sir, your voice is little breaking.
Okay, ma. No. Now can you hear me?
Yes, sir.
No, clearly. Yeah, fine. We'll continue. At the rest mass of neutrino is 0. So almost all the energy is carried by neutrino only. So therefore, what is energy? This one 0.8695. I'll say the energy of neutrino how much now? Should be equal to K gamma equal to Q. So then we know momentum is considered momentum of now daughter, or so the kinetic energy of the daughter should be equal to Py square by 2 times mass of the daughter. This should be equal to momentum of neutrino daughter. So this should be equal to momentum of neutrino. and how the momentum and this are related. So kinetic energy of the neutrino should be equal to P gamma, but we can't express what, like the kinetic energy of the neutrino is what, equal to Q only. So therefore, what shall we write here? No, Ky has to be determined. Is asking very specifically. So how to bring that Ky? Shall we write equal to 0.8695? That is carried by the neutrino. Almost, actually, it will both will share, but we don't know rest mass of the neutrino. No, it is 0. So how to express this kinetic energy of lithium? I have one thing like I brought. Do we know momentum of neutrino? No. There's only one help is what I'm having. So don't say 0. Ky will not be 0. It will have some energy. And that will be taken very least value, that one. That has to be determined. Can we write this Q should be equal to Ky plus K neutrino? Approximately, we can take it this way here. Since the rest mass of neutrino, we don't know. If we know mass, then I can bring some equations. A neutrino, can we use some formula like SC by lambda or any other thing, the momentum? Let me try that. Okay, this is the kinetic energy of the daughter, no, what we needed. So we wanted expression. So for that, momentum of neutrino is needed. K alpha, lambda K alpha, okay, that will come afterwards. That is not at all needed here. Q is equal to Ky plus K neutrino. We don't have equation, no, here. We can't bring, I think. K neutrino is here. Ky, I can write it as Py square by 2my. P neutrino. Kinetic energy of the neutrino will be, we don't know mass of the neutrino. We can't express. But how this option D has picked up? Conservation of momentum, okay, the rest mass. Can we find out physically? Neutrino, we know kinetic energy of the neutrino. From the kinetic energy, can we calculate its momentum? Not possible, no? There's a recoil energy of the I did some calculation. So how I brought it? Because we don't know rest mass of neutrino. So that M will become undefined term, will be 0. So M0, I think we can't work out. Then how do they find out? And moreover, it will not so like a interact with the matter. This will have a slight recoil. I think that is not possible. He has given option, but we cannot determine recoil energy of the daughter. From where I picked up? Let me check the data once. Recoil energy of the daughter. Any data is missing. Rest mass of neutrino is 0. Yes, clearly mentioned. So we can't. This will be very difficult. Nearly stilling. Okay, we'll just have here because let's not introduce any new concept on our own. Most of the energy will be carried by the neutrino only, and the atom and the recoil it will have a very less speed. So there's the equation what we can write further. I'll take it out this. Let it be here. If you know how much of energy carried by k neutrino, then we know energy leaves, then we can say anything about this particular thing. For that, we should know the momentum of neutrino. If they give that information, yes, we can work out. So some data problem. I will just stop it here only. Cannot be concluded with the given information. I'll write it here. Maybe it's a true option, but we don't have the information to further proceed. No, this is about next again is telling the option since rest mass of neutrino 0, it does not carry energy. No, it will carry energy. It will only carry maximum energy. Almost all the energy is carried by neutrino. The option C is ruled out. What about option A and B? The X-ray will be characteristics of daughter nuclei. Yes, it is correct, no? Because Z-1 is the charge it will see now. So not like Z. So when you write lambda k alpha, Z-1 is what you have to write in the Moseley's law. So therefore, this should be the characteristics of the daughter nuclei. So this data is very important. The option B, for lambda k, when you're writing expression the Moseley's law, you have to write Z-1, not Z. Agreed? This K capture, till now, they didn't ask in advance or even in mains. So all possibility of asking. Any of the data they can ask you, just do revise once because there's a totally till now they didn't ask, they didn't touch. And it's a part of syllabus also.